All right, section 3.1, we are going to talk about derivatives of functions. So let's get started here. Before, up until now, you were given this equation. M equals limit as h approaches 0 of f of a plus h minus f of a divided by h. Right? And we said this is the derivative of a function at x equals a, the derivative of a function at a point. So we could find the slope of a tangent line at a given point, a comma f of a. All right? And so now what we want to do is extrapolate this to any value for x. In other words, wouldn't it be fantastic if instead of computing the slope of a tangent line at a particular point, if we just had a function whose output was the slope at any point? We might call that function something like so where previously, like this, we said this is also equal to f prime of a, right? Wouldn't it be awesome if we could come up with a function, maybe something like this, called f prime of x, whose input was whatever x value you wanted, but whose output was the slope of the tangent line at that point. And so that's what we're going to work on today. And it turns out we can extrapolate that limit that I just showed you and that we've been talking about in this way. So we can write this. F prime of x is equal to the limit as h approaches 0 of f of x plus h minus f of x divided by h. Okay? And this is called the derivative of f with respect to the variable x, called f prime. And so you can read this as f prime of x, or again, the derivative of the function f at x. Okay? So if, what else do I want to say here? Obviously this limit has to exist for the derivative to exist. If that limit doesn't exist, then the derivative of the function doesn't exist. This is, one other thing you might want to write down is that we say this: if f prime of x exists, then we say it's differentiable. Okay, so that's an important word. If it's we say that it's differentiable. We will talk about differentiability a lot, especially in section 2. All right, now, to find this function, the derivative of f, what we need to do is, there's really two ways to approach it. I'm going to show you what I call the four-step process. Right? Now, you might see that and think, I can do this without the four-step process. And if you can, then that's fine. But I'd like you to at least do a couple with the four-step process first, so that you're comfortable with it. Here are the 4 steps. Okay, step 1. Find f of x plus h. Step 2. Sorry, I should have written that correctly. Right, what I say. Find f of x plus h. Okay, step 2. Write f of x plus h minus f of x. And then simplify. At this point, each term should have an h. Okay? So you might want to write that down, that each term should have an h at this point. If it doesn't, go back and try again. You've made a mistake. All right, step 3. Write f of x plus h minus f of x, the thing you just found, divided by h. Simplify. Okay. Step 4. Then finally take the limit. Okay, so take the limit of limit as h approaches 0 of the thing that you just found. So f of x plus h minus f of x all divided by h. start from here, work your way down. By the time you get here, you should get f prime of x. The reason we break it into small parts is because sometimes students struggle with putting all of this information, f of x plus h minus x, all into that limit right from the beginning. It's a lot to keep track of. You do the 4 steps, everything works out fine, and you're less likely to make a mistake. And if you do make a mistake, it's easier to pinpoint where you made it, okay? So again, if you get to 2, and there is not an h in each term, go back and try again, okay? All right, let's do a couple examples here. Now, the one thing about these kinds of functions, about finding the derivative with, this is called the definition of a derivative, with the definition, is that they can be sort of obnoxious algebraically, okay? So, well, all right, let's see how this goes. I don't know how much more juice this marker has, but I guess it's okay for now. All right, so here's what we want to do. In example 1, we want to find f prime of x given f of x is equal to 2x squared plus 3x, minus 3x plus 4. All right, so in fact, I should probably call this, let's call this example A instead, sorry, because I'm about to do the 4-step process. All right, so step 1 in the 4-step process is find f of x plus h. So let's do that. Okay, what this means is that everywhere I see an x in f, I'm going to put x plus h. Okay, so it will look like this. Let's see, we'll have 2 times x plus h squared. Use another color here for your learning convenience. 3 times, again, x plus h plus 4. All right, then simplify. So this is a point where you might want to try this one actually on your own and see how you do. Try going right through the 4-step process. All right, so let's simplify this. I'm going to get, this will end up being, and you'll have to trust me a little bit, I just want to save myself a little bit of writing. This is going to be 2x squared plus 4xh plus 2h squared. Remember to square this, you have to FOIL it, and then distribute the 2. Okay. Minus 3x minus 3h plus 4. Okay. So there's step 1. Step 2. We're going to find f of x plus h minus f of x. Okay, so you take the expression that we just had here, and then we're going to subtract f of x. So here's what we get. 2x squared plus 4xh plus 2h squared minus 3x minus 3h plus 4 minus 2x squared minus 3x plus 4. Okay? Ugh. All right, let's see what cancels or simplifies out here. So I have 2x squared, and I'm just going to distribute the negative here. Sorry. Minus, plus, minus. Okay? So I have 2x squared minus 2x squared. I have negative 3x plus 3x. And I have plus 4 minus 4. And let's clean that up. So now I have that this is equal to 4xh plus 2h squared minus 3h. Okay? So hopefully you've written that down. I'm going to erase this so I have room for steps 3 and 4. Okay, so here's step 3. Step 3 says take the fraction, right? So take f of x plus h minus f of x, what we just computed, and divide that by h. So that will be this expression here, 4xh plus 2h squared minus 3h all over h. Now I made sure that I had an h in each expression when I got done with 2, and I did. And when I got done with step 2, I did, so now I'm here. I'm going to factor an h out of each term here. So this will end up being h times 4x plus 2h minus 3. Okay, all divided by h. H over h simplifies to 1 over 1, so I'll be left with just this expression here for step 3. Step 4 says finally take the limit as h approaches 0 of that expression there, 4x plus 2h minus 3. Now I didn't rewrite it, but this is our final expression out of step 3, okay? So evaluate the limit. Now I can use direct substitution because I'm not dividing by h. I'm not dividing by 0. So this will end up being, let's see, 4x plus 0 minus 3. So I end up with 4x minus 3. Whew. Okay, there's a lot going on there. We just did a bunch of algebra. Let's write our final answer then. We can write this. F prime of x is equal to 4x minus 3. That is the derivative of the function. That has significance because it will output the slope of the tangent line at any x value. So if you want to know the slope at -3, you just plug in -3 into this. It will give you the slope of the tangent line in the original function here. Okay? So that's the first example. I think I'm going to do a different video, a second video, just to break it up a little bit on the next example, which has a square root in it, which students always love. So that's at least the beginning here of 3.1.